Now let's try movies 3 and 5. There's another example. So we'll go through again and we'll see 3 and 5. Now A works, so we'll just do next to it, we'll say check mark. We can use A because A has rated movie 3 and he's rated movie 5. We can use B, again, because B is rated movie 3, movie 5. We can't use 3 because this is part of the test set. Sorry, it's not part of the test set. This is value that we don't know. We can use user D right here because we know both these values. We cannot use E because we don't know this is part of the test set, and we cannot use F because this is part of the test set. But we do have 3 values now, 1, 2, 3 on each of these sides. So we have to do a little more. There's a little more terms here. So now we do this the same as last time. It's just we have 3 terms that we're summing instead of just 2. So we do this times this plus this times this plus this times this. So we have -1 times -0.43 plus -0.25 times -0.10 plus 0.25 again times -0.10. They actually turn out to be the same for both of those. Then we divide by the square root of this squared plus this squared plus this squared times the square root of this squared plus this squared plus this squared. So we do the square root of 1 squared plus 0.25 squared plus 0.25 squared times the square root of 0.43 squared. Notice I'm omitting the square root, and that's because when you square something, it becomes positive again, so I don't need to write the square roots. Plus 0.1 squared plus 0.1 squared. And we do this. If you do this whole thing out, this entire multiplication, I'll leave it to you to actually run through the calculation, but you get 0.79 right here. And so that's closer to +1, right? So it's a positive correlation, and it's kind of close to +1. So we would say that these movies are positively correlated, right? So now we can use this and we can come up with a full table of similarity values. And here I'm tabulating this. This is similarity between 1 and 2. You can see the similarities between also 3 and 5, 0.79 we just found, and so on. And now, a couple things to note. First is that this table is symmetric, right? So we've said before that things sometimes aren't symmetric, but here they are. So the similarity from 1 to 2 is the same as the similarity from 2 to 1. So that's why 1 and 2 and 2 and 1 are the same. Just like take 2 and 4, for instance, and 4 and 2, same. So you can flop it over this, and or if you mirror image it over, it would be the same. Now, in the next segment, we're going to choose one neighbor or movie, right? So we're having the neighbors be movies here. For each movie, we're going to choose one neighbor. And we could choose more. We could choose 2, 3, or 4, but we've already made the math complicated enough, and that would get even more complicated. So we'll just stick to choosing one neighbor for each movie, which will simplify things a lot when we actually go to do it out. And so basically down the columns right now, we'll say movie 1, we want to try to find the neighbor with the highest similarity, right? And so that's that would be 3 here, right? And these are all of the backgrounds now of green, which are the similarities, or the ones with the high similarities. So 1 would choose 3 as his neighbor for that reason. And again, remember, we're finding the magnitude, so we want the magnitude to be the highest. So even though this is negative, very negative, it's still really negatively correlated, which is a useful thing. And now for 2, we're going to choose 1. We choose between 0.11, 0.74, 1, and 0.88. And therefore, we're going to choose this. Even though, again, it's negative, it's still the highest in magnitude. For 3 would choose 1 because it's got negative 0.82, which is higher than any other values in magnitude. 4 would choose 2, just like 2 chose 4. Those are actually perfectly negative correlations with one another. So 4 and 2. And the reason that they're actually perfectly negative correlation is because there's only one value that we're multiplying here. And so that's not really that great. I mean, normally you need more data before you could say that two things are perfectly negative correlation, but here that's just the way it turns out. Now 5 will actually choose 2 to be his neighbor, right? Because 0.88 is higher than any other values. Now notice that 2 did not choose 5. 2 chose 4, but 5 chose 2. So they don't have to choose each other. Even though the table is symmetric, they don't necessarily choose each other. And we could define other metrics. For instance, we could say, all right, well, I'm not going to use similarity at all unless the similarity value is higher than like 0.9, for instance. And then in that case, we would only use one neighbor for one pair. Here, we wouldn't use similarity at all. Some people do that because sometimes it makes sense to say, well, unless similarity is high enough, I'm not going to use it. But here we're just going to choose the most similar and just use that to do our calculation.